Hello everyone. Sí. Hola a todos, ¿cómo están? ¿Todo bien? El día de hoy vamos a trabajar. Vamos a trabajar. Vamos a trabajar en CS50 Python. CS50 Python. Entonces, este ya es el módulo, creo que 8, 9, me parece. Me parece que es el 8 o el 9. Déjenme ver aquí. Vamos a ver en cuál estamos. Ya. No sé qué es esto. Vamos a regresar. A ver, lo que tenemos que hacer. Estamos en el módulo 8. Ok, estamos en el módulo 8. Qué calor que hace. 8:28, 29 de junio. Estamos en el módulo 8 de Introducción a Programa de Python. He hecho todos estos módulos hasta ahora. Mi nombre es Absalom y vamos a trabajar en el módulo 8. Yo no he visto los videos todavía, así que el día de hoy básicamente voy a dedicarme a ver los videos y pues nada, vamos a ver los videos en este momento a ver qué tal nos va.
All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on Object-Oriented Programming, or OOP. It turns out that in the world of programming, there's different paradigms of programming languages. There's different ways of solving problems with code, and it's a little hard to see this at first if you've only learned one language, but over time, if and when you learn other languages besides Python, you'll start to notice certain patterns and certain capabilities of some languages, but not another. Thus far, within the world of Python, you and I have largely been writing code that's procedural in nature, whereby we're writing procedures, we're writing functions, and we're sort of doing things top to bottom. Everything is step by step by step, as you would expect in general from an algorithm. But along the way, we've actually dabbled in another paradigm known as functional programming with Python, whereby we've been able to pass functions around. We even had an anonymous function some weeks ago, and that's evidence of features of a functional programming language, even though we've just scratched the surface thereof. Today, we focus on another paradigm, and this one in more detail, namely object-oriented programming. And now, while some of you might have prior programming experience and have learned languages like Java, which are by design fundamentally object-oriented, Python indeed allows you a bit of flexibility when it comes to how you solve problems with code. But it turns out OOP, object-oriented programming, is a pretty compelling solution to problems that you invariably encounter as your programs get longer, larger, and more complicated. So indeed, OOP, for our purposes, is going to be a solution to a problem that builds on so many of the lessons past. So let's go ahead and do this. Let's start by writing a program very procedurally by opening up VS Code here. I'm going to go ahead and create a program called student.py. And in this program, I want to do something relatively simple initially, as we might have done.
Ok, entonces yo voy a hacer lo mismo. Vamos a abrir mi CS50, mi red, no, mi entorno virtual. Entonces, para abrir mi entorno virtual, creo que voy a ir para acá. No sé si se está transmitiendo esto. Sí, se está transmitiendo. Voy a verla un poquito más acá. Entonces, ya. Entonces, lo que yo voy a hacer es ir, creo que más abajo, más arriba. A ver, lo que tengo que encontrar es esto, CS50, el de Python. Es una página, no recuerdo de dónde lo sacaba, pero es una página que me permite subir las tareas y subir los proyectos. Eso siempre está aquí en Problem Set 8, porque ahí se suben las tareas, los proyectos. Le doy clic aquí y van a ver que abajo dice Login into CS50Dev. Entonces le doy clic aquí, Login into CS50Dev. Y aquí vamos a poder ver Login. Le damos Login y listo. Aquí nos van a pedir que abramos. Yo creo que lo voy a abrir con uno de mis correos. Y en teoría debería funcionar ya esto. Ya. Ok, entonces vamos a ver. Este es el entorno virtual, es el mismo que está mostrando él, sí, es lo mismo, solo que lo tengo en negro porque me gusta más que no brille tanto. También lo puedo tener en blanco, creo que hay una opción por aquí para ponerlo en blanco, pero me gusta así. Creo que en ver. Muy bien, bienvenidos, cerramos esto. Estas son las cosas que tengo. Ok, adieu, bam, tantas cosas. En Hello sí, este es un documento que creo que no quiero tener. Se voy a eliminarlo. Ahorita me salió negro porque creo que yo le puse este formato negro en configuraciones. De alguna forma yo lo debía haber puesto. Acá tenemos hello.py. No recuerdo por qué está este hello.py. Creo que aquí en este hello.py lo que hago es poner cosas, nada más. O sea, poner documentos, no, poner código que quiera yo guardar. Y nada, solo eso. Explorador, motores abiertos, no sé qué, motores abiertos, motores abiertos, ni idea. Bueno, entonces voy aquí a abrir un... Está muy bien todo esto. Voy a abrir aquí un documento, ya existe hello.py. Básicamente, aquí voy a escribir las cosas que nos estén comentando. Esto lo voy a borrar, creo que sería lo mejor borrarlo. Sí. O mejor guardarlo como código. A ver, vamos a crear un documento más. Para crear un documento más lo podemos hacer aquí mismo con la interfaz. O para practicar, creo que también se podía hacer por... Vaya, también se podía hacer por esto de la terminal. Creo que era code, ¿no? Entonces ponía el nombre del documento que vamos a ponerle módulo 8. Módulo 8, .py. .py es con un punto .py y listo, debería coger. Ahí se crea un documento de Python y con esto ya puedo empezar a editar. Entonces lo que voy a escribir aquí es lo que vaya aprendiendo en este Mr. ¿Cómo se llama? No recuerdo.
Some weeks ago now, where I just ask
David.
a user for their name and maybe in the context of the Harry Potter universe, their house, and just print out where that student is from. And let's gradually enhance this program by adding more and more features to it and see if we don't stumble upon problems that up until now we might not have had very elegant, well-designed solutions to, but if we introduce explicitly object-oriented programming as a programming technique, I bet we can clean up our code and set the stage for writing even more sophisticated programs, longer programs down the line. So in student.py, let me go ahead and do a name variable, setting it equal to the return value of input, and just prompt the user for their name like this. And then let me go ahead and do the same for a house variable and prompt the user for their house using input like this. And let's do something super simple now. Let's just go ahead and print out an F string that says something like name from house, just so that I can confirm that the contents of these variables are indeed as I expect. I'm not going to do any error checking or trimming or anything like that for now. I'm really just going to spit back out whatever the user just typed in. All right, let me go ahead and run Python of student.py. Let's use our go-to, like Harry, as in Harry Potter, from Gryffindor. And when I hit enter now, let's see if I see that Harry from Gryffindor is indeed the case. All right, so I think we have a working program at this point, But let's now introduce some of those lessons learned way back from week 0 where we started writing our own functions. Not necessarily because it solves the problem more correctly. I dare say this is correct as is, but it begins to give us building blocks that we can extend so as to solve more complicated programs. So let me go back up to student.py. And let's go ahead now and do this. Let's put the entire logic I just wrote inside of our typical method called main, and let me indent those 3 lines so that at least they're now combined into one main method. But instead of using input on line 2 and input on line 3, why don't we go ahead and assume for the moment that we've got some function called getName in the world, and let's go ahead and assume we've got another function like getHouse in the world that don't take parameters, but their purpose in life is, by their name, going to be to get the user's name and to get their user's house respectively. And then I'm going to print out the exact same f string as before. I, of course, need to implement these functions now, so let me go lower in my file and define a function called get_name. Nothing in these parentheses because it's not going to take a parameter. And I'm going to go ahead and do something like name equals input, quote-unquote name, just like before. And then I'm going to go ahead and return name. So it's a super simple function, but it's an abstraction. I now have a function called getName whose implementation details I don't have to care about anymore. I just know that the function exists. And I can tighten this up, in fact. I don't really need a name variable on line 8 if I'm immediately going to return that same name variable on line 9. So let me just tighten this up a little bit, even though it doesn't change the functionality, and just immediately return the return value of the inputs function call here. Let's do something very similar now for getHouse, which will similarly take no arguments. I'm going to go ahead and return the return value of input, this time prompting the user for their house. And I need one final detail at the very bottom. Let's continue our habit of doing if the name of this file equals quote-unquote main, then let's go ahead and actually call main. And recall that we have that in place so that if this eventually becomes part of a module, a library of sorts, I don't accidentally call main blindly. I only do it if I mean to run main from the command line on this file. All right, so if I didn't make any mistakes here, let me go ahead and in my terminal window again run Python of student.py, enter. Let's type in Harry, enter. Let's type in Gryffindor, enter. And we're set. Harry from Gryffindor seems to still be working. So we haven't really solved the problem any more correctly, but I've laid the foundation to maybe now do some more interesting things because I've had these building blocks in place. All right, but let me propose that we could be doing this a little bit differently. getName, getHouse is fine, but at the end of the day, I'm really trying to get a student from the user. I want their name and their house, not just one or the other. So maybe it would be a little cleaner still to define a function called getStudent and let getStudent do all of this work for us. Now, theoretically, getStudent could call getName and could call getHouse, but because these functions are so short, I think I'm okay with just defining one function called getStudent that similarly won't take any arguments, but it's going to do 2 things. It's going to get the student's name by prompting them with input as before, and it's going to get the student's house by also prompting them as before. And then, now, I want to return the student, but I think I might have painted myself into a corner here because I now have 2 variables, name and house, and yet up until now, we've pretty much returned one or the other. We've returned one value. So any suggestions for how we can perhaps solve this problem that I just created for myself, whereby I want to return really a student, but I currently have a name variable and a house variable? I'd minimally like to return both of those.
I believe that we can return a dictionary, include the name and the house.
Yeah, so we absolutely could return a dictionary, a dict object in Python, whereby maybe one key is name, one key is house, and the values thereof are exactly the values of these variables. So we could totally do that. I worry that that might be getting a little complicated. I wonder if there's a simpler way instead. Any other instincts, even if you're not sure it would work?
Return both name and house.
Return both name and house. I like the sound of that. It sounds simple. I don't have to figure out what a dictionary is going to look like. And in fact, this too would be a valid approach, even if you've not seen this before. It turns out in Python that you can kind of return multiple values, but that's a bit of a white lie. Or we could take Mohammed's approach of actually returning a dictionary and putting multiple keys therein. So here again, we have yet another example of how you can solve the same problem in at least 2 ways, and I dare say we're about to see even more. So one way you could solve this problem, whereby you want to return multiple values, would be to do something like this. I could go ahead and literally return not just name, but I could put a comma and also return house. This is not necessarily something you can do in other languages if you have programmed in other languages before. It depends on the language. But it looks like, thanks to this comma, maybe I can, in fact, return two values as actually proposed. Well, if I'm returning two values in this way on line 10, how do I get both values at the same time? Well, there's a couple of ways. Let me go up to my main function. I know minimally I'm going to have to change the get name and get house to get student, but what am I going to store the return value in? I think I could actually do this. And we have seen this technique before where you can unpack, so to speak, sequences of values that are coming back. And indeed, consider this to be exactly that. Name, comma, house is some kind of sequence that I'm returning of values. Name, comma, house. So if I want to unpack those and store the return values in two separate variables, I can, in fact, use the commas on the left-hand side of my assignment operator, the equal sign, to do just that. Now, to be clear, I don't need to call these variables name and house here. I could simplify this and use just n here and h here, and then I could return just n and h. But I would argue that's not very clear to the reader as to what's going on. So I think in this case, even though it's a coincidence that I've used the same variable names in getStudent and getMain, and in main, it's a little more readable to someone like me. So I'm going to leave it as is. Well, let's go ahead and see now if this works. Let me clear my screen down here and run Python of student.py, enter. Let's again type in Harry. Let's again type in Gryffindor, enter. And voila, we still see that Harry is from Gryffindor. But what are we actually doing here? What are we actually doing by returning this value? Well, it turns out that what we've just done is used a tuple. A tuple is another type of data in Python that's a collection of values, x comma y or x comma y comma z. It's similar in spirit to a list in that sense, but it's immutable. It's not mutable. Now, what does that mean? A list, as we've seen it before, is a data structure in Python that you can change the values of. You can go into bracket 0 for the first location and change the value there. You can go to bracket 1, bracket 2, bracket 3, and actually change the values in lists. But if you have no intention of changing the values of variables and you want to return effectively multiple values, you don't have to even return it as a list. You can return it as a tuple instead, just by using a comma. And it turns out we can make explicit that, here's the white lie, I'm not actually returning two values per se. Whenever you use a comma in this way on line 9, you're actually returning one value, which is a tuple. Inside of that tuple now are two values. So it's similar in spirit to returning one list with two things. Here I'm returning one tuple with two things. And the mere fact that I've used a comma and nothing else tells Python that I indeed want to return a tuple. But there's more explicit syntax that we can use instead. I can actually more verbosely put explicit parentheses around the values of this tuple just to make more clear to me, to the reader, that this isn't two values per se. This is one value with two things inside of it. And what I can actually do then, too, is I don't have to unpack this up here, so to speak. I can actually go up here and maybe give a more apt name like student. And I can name the value, or rather name the variable in which I'm storing the return value of getStudent as, quote unquote, student. So maybe this is a little better design now because I'm sort of abstracting away what a student is. It's implemented at the moment as a tuple with two values, but at least now I have a variable called what I mean, a student. But there's going to be a catch. On line 3, I still want to print out that student's name and their house, but I don't have a name variable anymore, and I don't have a house, and I also don't have a dictionary, as was proposed earlier, so I can't even go at those keys by name. But what a tuple is, it's very similar in spirit to a list, but it is indeed just immutable. And what I mean by that is I can still index into it numerically by saying student, square bracket 0, for the item in the first location in that tuple. And then over here, instead of house, I can say student bracket 1. Student bracket 1 is going to give me the second location in that tuple. Let me go ahead and clear my terminal window. Again, run Python of student.py. Let's type in Harry. Let's type in Gryffindor, enter, and we still have some working code.
Ok, creo que entendí esto. Básicamente nos dicen que tenemos que... A ver, vamos a definir... ¿Correcto? Creo que era así. Les digo la verdad, me olvidé la sintaxis por completo. Sí. Me olvidé de todo, todo. Tengo que recordar. Básicamente es así. Ya. Y aquí lo que vamos a hacer es asignar a la variable student el valor de getStudent, un programa que va a solicitar, y luego vamos a poner print, y lo que vamos a printear es student bracket 0. O sea, vamos a tomar esto from y le vamos a poner student bracket 1. Al poner esto es obligatorio poner los brackets justo antes de poner una variable. Este no lo pongo con bracket porque no es una variable, es una palabra dentro del print. A ver, y luego vamos a poner def main, ya lo hicimos. Abajo quedaría definir el programa getStudent. GetStudent no queda más que ponerlo, definirlo como pídele el nombre, name es igual a input name, sí, creo que sería así. Entonces input name y house sería igual a input house. Ya. Luego de eso vamos a return name y house. Ya. Y luego de eso vamos a poner que if underscore name underscore is equal main underscore main, entonces ejecuta main. Creo que es así. Vamos a ver. Sí, if name is equal a main, ejecuta main. Ya.
Let me pause here now and see if there are any questions on this technique of returning a tuple and indexing into it in this way.
I guess what's like an actual use case where you would use a tuple versus,
Cierto, no probamos el código, vamos a probarlo. Probarlo significaría poner clear para limpiar todo, poner sería aquí definir main. No, creo que sería primero ir a es como a ver, primero tenemos que sí, solo tenemos que poner Python, el nombre del documento, y creo que sería todo. No, era cómo ejecutábamos el programa. Python módulo 8. Ahí funcionó. Name accent. No me sé cómo se escribe, pero creo que es. Vamos a poner que está aquí. Accent from. Ya. Funciona. Funciona, funciona. Funciona. Vamos a ver qué más nos dice.
A list or something else that's similar.
It's a really good question. When would you use a tuple versus a list? When you want to program defensively, or in general, when you know that the values in this variable shouldn't change. So why would you use a data type that allows them to be changed? It just invites mistakes, bugs down the line, either by you or colleagues who are interacting with your code. So tuple is just another way where you can increase the probability of correctness by just not letting anyone, yourself included, change the contents therein. So it's just another tool in your toolkit. But let's make clear then what I mean by immutable. Again, I claim that immutable means that you cannot change the value. Well, let's go ahead and try to do this. Let me go ahead and run this program once more as is, Python of student.py. Let me go ahead and type in, for instance, how about Padma's name, and I'm going to go ahead and say that Padma's in Gryffindor, as in the movies, and we see Padma from Gryffindor. But technically, I went down this rabbit hole and looking at Harry Potter more closely, technically in the books, Padma, I believe, was from Ravenclaw. So this is actually a mistake or an inconsistency between the movies and the books. Let's see if we can't fix this inconsistency in our code. So how about we do this? If the student's name that's inputted equals Padma, why don't we override whatever the house is and change it to be properly Gryffindor? Let me go ahead and do if student. Now, if I want to get at Padma's name, I'm going to have to do student bracket 0. I have to know what location the name is in this tuple. But if that value equals Padma, let's go ahead with this if statement and make a change. Let's change the student's bracket 1 value. So the second value, if we're 0 indexing, let's change it to be another house in the world of Harry Potter called Ravenclaw. So I'm just fixing maybe the user's input. They watch the movie, so they type in Padma Gryffindor, but in the books, it was Padma from Ravenclaw. All right, let me go ahead and go down to my terminal window, clear my terminal, and do Python of student.py, enter. I'm going to do Harry as well as Gryffindor, just to demonstrate that that is still working as intended. Let me clear my screen again, though, and run Python of student.py on Padma, and I'll put her too in Gryffindor, as in the movies, and hit enter. And now I just see a big mess of errors on the screen. Some kind of exception has been thrown, and indeed, a type error has happened. I'm using a data type wherein there's an error. And what is that error? Well, tuple object does not support item assignment. It's a little arcanely expressed, that is, that's not really very user-friendly. But if you think about what those words mean, tuple object does not support item assignment. So assignment is copying from right to left. So somehow that's invalid. And here is a manifestation of the immutability those words mean. Tuple object does not support item assignment. So assignment is copying from right to left. So somehow that's invalid. And here is a manifestation of the immutability of tuples. You cannot change location 0 or 1 or anything inside. That is a feature. That is the design of a tuple. So if I want to override that, I think I'm going to have to use a different type of data that we've used before, namely a list. And that's fine. If you want to enable yourself and colleagues using your code to change the contents of that container, well, we can go ahead and return not a tuple using explicit parentheses or no parentheses, just the comma, but I can use square brackets. And if I'm using square brackets on the left and the right, this is indeed explicitly a list. Same idea, but it's mutable. That is to say, you can change the contents of a list. So making no other changes, just returning a list with square brackets instead of a tuple with parentheses or just the comma. Let me go ahead now and run Python of student.py, enter. Let me type in Harry and Gryffindor again. That's still working. Good to see. Let me run this once more and type in Padma and Gryffindor, as in the movies, but no, now we've corrected it to be Padma from Ravenclaw, as in the books instead. Any questions now on tuples versus lists, or this idea of immutability versus mutability?
Can we use a nested tuple in Python, like a nested list?
Absolutely. You can have not only nested lists in Python, where one of the elements in a list could be another list. So you have some square brackets out here. You might have some other square brackets inside. You can absolutely do the same with a tuple as well. There's no constraint on the types of values you can put in there. We've not had occasion to do that in this case. I'm just returning a simple tuple with 2 elements. But yes, you could absolutely do that too. Other questions on tuples versus lists?
Okay, for example, when I say the square bracket, is it mainly used for the list?
Oh, a really good question. Sort of. So when you create a value, like a list, you use square brackets, and that would indeed be a visual indicator that this is definitely a list. If you instead see parentheses, that's a visual indicator when creating a value that it's definitely a tuple. However, somewhat confusingly, both lists and tuples use square brackets when you access the contents of them. When you index into them at location 0 or location 1, you always use square brackets. So that's the distinction there. Good question. Allow me to propose now, if I may, that we solve this problem yet another way, and let's see if we're either making things better or for worse than us. Recall that dictionaries, or dict objects, also exist in Python, and a dictionary is this collection of keys and values. And the upside in particular of a dictionary is that they have better semantics, right? You don't just have to assume that a name is always going to be at location 0, house is always going to be at location 1. I mean, that's the kind of thing, especially if you had 3, 4, or more values, eventually you or someone is going to get confused and forget what the order is, and you're going to write buggy code. So a dictionary is a little more powerful in that you can semantically associate keys, like little descriptions with the values, those keys and those values respectively. So let me go ahead and do this, and we can do this in a few different ways, but let me propose that we focus on getStudent here. And let's go ahead and do this. Let me go ahead and delete the implementation of getStudent as is. Let me create a student variable and initialize it to an empty dictionary. And I can do that with just 2 curly braces here. And then let me go ahead and set 2 keys inside of that dictionary. Inside of the student, there will be, quote unquote, a name key. And the value of that is going to be whatever the return value of input is when I prompt the user for their name. And then the house key inside of that same student dictionary is going to be the return value of whatever the user types in for their house. And lastly, I'm going to go ahead and return student. So now I am literally returning one thing still, but this time it's a dict rather than a tuple, rather than a list. But there's still 2 things in it, technically 4 things if you count the keys and the values, but there's 2 key value pairs. Now my code up here is going to have to change a little bit, and let's simplify this and remove, for instance, now the Padma if statement, just to focus on what's changing at hand. And let me go ahead now and leave line 2 alone. I'm still going to have a student variable that gets assigned the return value of getStudent, but what I want to do here now is actually access the keys inside of that dictionary, not by numeric index, which was for tuples and lists, 0 and 1, but by way of their keys. Now, normally, I might be in the habit, as I personally am, of using double quotes, quote unquote name inside of there, and quote unquote house inside of there. But before I even run this code and show you a mistake, see an error on the screen, does anyone want to call out what I have done wrong here? This is just an F string. I just want to print out the value of the name key, the value of the house key in this dictionary, but your audio is a little garbled for us, but I think I heard double quotes and single quotes, so I'm going to assume that indeed you've identified precisely the issue. I'm just going to confuse Python right now. Even though this is an F string inside of double quotes prefixed with an F, I can't actually use my double quotes inside my double quotes because that's going to potentially confuse Python. Indeed, if I run this program now, Python of student.py, and hit enter, I get a syntax error. So the program didn't even run fully. It just couldn't be understood because it got confused by those double quotes. So the simplest fix here would indeed just be to use not double quotes, but single quotes around the keys, or conversely, flip the double quotes on the outside to single quotes, then use double quotes on the inside. You just want to be consistent. So a subtle detail, but again, this is now specific to dictionary syntax. This isn't fundamental to how we're solving this current problem at hand. All right, well, let's go ahead and try this. Let me go ahead now and run Python of student.py. Let's go ahead and type in Harry. Let's type in Gryffindor, and hopefully Harry is back from Gryffindor. No syntax errors, no other errors. I think I'm back in business here. And what I do like to be clear about using a dictionary is that it is allowing me just better semantics. Again, I don't have to remember, memorize, document that 0 is name, 1 is house, Instead, name is name and house is house. It's just a little clearer, a little more expressive, so that's generally a good thing, especially if we stored more data about students than just their name and their house. If you had 3 fields, 4, 5, 10 different fields, no one's going to want to remember or be able to remember forever which is 0, which is 1, which is 2, and so forth. Better to introduce names like name and house in this case. But let me tighten this up further. Indeed, I'm typically in the habit of not introducing variables unnecessarily unless they make the code more readable. And an alternative way to format the same code would be this. Strictly speaking, I don't need to create an empty dictionary, then add 1 key to it, then add a 2nd key to it, and then return that dictionary. I can actually consolidate this all into one statement, if you will. Let me go ahead and do this. Let me go ahead and say name equals inputs return value, house equals inputs return value, and then instead of returning any variable named student, which I'm going to propose doesn't need to exist anymore, let me just create and return the dictionary all at once. Let me do quote unquote name in lowercase here, and then the variable, it's storing the user's name, then quote unquote house as my 2nd key, the value of which is going to be house, the variable. Now, is this better? Maybe, maybe not. Maybe the first way was a little more readable, and that's totally fine to create variables if they improve the readability of your code. But just know that you can also create and return a dictionary on the fly like this, so to speak, all in one line. And I think it's arguably pretty reasonable in this case. Why? It's just pretty short. I probably wouldn't do this if it got longer and longer and longer. I might minimally then start moving my key value pairs to separate lines. But this would just be a slightly more compact way of doing this as well. But let me propose we do one more change. Let's go ahead and introduce that same special casing of Padma to fix her house, from Gryffindor, for instance, to Ravenclaw. How do we do this with dictionaries? Well, dictionaries, like lists, are mutable. You can change what is in them just like you can lists. How do you do that? It's just a little different syntactically. So let's go back into main and do this fix. If the student variable has a name key that equals Padma, then, indented, go ahead and change the value of the house key inside of that student dictionary to be, quote unquote, Ravenclaw instead. So very similar in spirit to what we did with a list, but instead of using location 0 and 1, we're much more clearly, explicitly, semantically using, quote unquote, name and quote unquote house, because you index into lists and tuples using numbers, but you index into dictionaries using strings, as I've done here. All right, let me go ahead and run Python of student.py. We'll again do Harry from Gryffindor, and I think all is well. Let me run it one more time, this time with Padma, who in the movies is from Gryffindor, but should really be from Ravenclaw. All right, any questions then on this progression from tuples to lists to dictionaries? We haven't necessarily introduced anything new other than those tuples, which have been available to us all this time, but the goal at the moment is just to demonstrate this distinction among these different data types and how they each work a little bit differently.
What if a combination of lists is there in a tuple? So is the list, like we can change the list because tuple are immutable, but lists are mutable?
Correct. You can change the contents of lists, and you can put most anything you want in them, other lists or strings, as I've done, integers or anything else. Tuples, you can do the exact same thing, but you cannot change them once you've created them. A dictionary is more like a list in that it is mutable. You can change it, but the way you index into a dictionary is by way of these keys, these strings, as we keep saying, rather than by numbers, those numeric indices. All right, well, let me propose that there is yet another way of solving this problem, and indeed, I would argue that there's now an opportunity at hand. Even though this program isn't particularly complicated, all I'm doing is collecting a name from the user and a house from the user. You could imagine wanting longer term to collect even more information, like the student's Patronus or magical spell or a whole bunch of other information that might belong in a student. And right now, we're just kind of using these very general purpose data types in Python. A tuple to combine some values together, a list to do the same, but let us change it later, a dictionary, which is more powerful because it's a little more structured. It does have keys and it has values, not just values, But you know what? We wouldn't have to be having this conversation if the authors of Python had just given us a data type called student, right? Wouldn't it have been nice if there were just a type of variable I could create in my code called student? Then we wouldn't have to figure out, well, do we use a tuple or a list or a dictionary? But that's pretty reasonable, right? You can imagine just how slippery of a slope that is, so to speak, if the creators of a language had to anticipate all the possible types of data that programmers like you and me want to store in your programs. So they just gave us these general purpose tools. But they gave us another general purpose tool that's going to allow us to create our own data types as well and actually give them names. And that terminology is a class. A class is kind of like a blueprint for pieces of data, objects, so to speak. A class is kind of like a mold that you can define and give a name, and when you use that mold or you use that blueprint, you get types of data that are designed exactly as you want. So in short, classes allow you to invent your own data types in Python and give them a name. And this is a primary feature of object-oriented programming, to be able to create your own objects in this way, and in the case of Python and classes, even give them some custom names. So what does this mean in real terms? Well, let me go ahead and come back to VS Code here. And let me propose that we introduce a little bit of new syntax. I'm going to go ahead and clear my terminal window first. I'm going to go to the top of my file, and I'm just going to start a thought but not finish it yet. I'm going to use this new keyword for classes called literally class. So indeed, the new keyword we're going to have here, and if I go back to our slides here, this would be the official URL where you can read up more on this particular feature of Python in the official tutorial. Class is a new keyword we can use. Now, this is coincidentally related to students, because students take classes, but it has nothing to do with the fact that we're dealing with students. Class is a general purpose term in a lot of languages, Python among them, that allow you to define these custom containers with custom names for pieces of data. So let's go back to VS Code. Let's use this new keyword, and let me propose that we create a class called student. And by convention, I'm going to use a capital S here, and I'm going to go ahead and, with a colon, get to later the implementation of this class. So I'm just going to use ... which is a valid placeholder for now, that just indicates to me that I'm going to come back to implementing this later. But as of now, it does in fact exist. I now have a student class defined for me that I can now use in my code here. How am I going to use it? Well, first of all, let me go down to get student, and let me change this code to no longer use a dictionary, but to use this class. I'm going to do this. I'm going to give myself a variable called student, as I've done before, but I'm going to set it equal to capital student, open parenthesis, close parenthesis. So I'm going to do what appears to be calling a function, and that function, student with a capital S, notice, matches the name that I gave this class at the top of my file. All right, what do I next want to do? I'm going to go ahead and give this student a name. Now, if I were still using a dictionary, I would say student, quote unquote, name using square brackets. But this is not a dictionary. It turns out classes have what for now we'll call attributes, properties of sorts that allow you to specify values inside of them. And the syntax for that happens to be a dot. We've seen dots before. We've used it in the context of modules and libraries more generally. This is another similar in spirit use of a dot that allows you to get at something inside of something else. So student.name is going to be the syntax I use for giving this student a name, and that name is going to be whatever the return value of name is. And then I'm going to go ahead and say student.house to give another attribute called house and give that the return value of input here, prompting the user for house. And then as before, I'm just going to return student. But now, what's really powerful about class and object-oriented programming more generally is that I've created this custom data type called literally student, capital S. I've stored one such student in a variable, like I can always do in a variable called student, lowercase s, but I could call it anything I want. It just makes sense to call it student as well, but lowercase for clarity. And then I'm returning that variable. And because of my syntax in lines 14 and 15, that has the result of putting inside of that class a name attribute and a house attribute. I just need to make one more change up here. I'm going to go ahead and remove our Padma code just so we can focus only on what's new rather than fixing her house. And I'm going to go in here and change the syntax that previously was for dictionaries. Again, dictionaries use square brackets and then strings in quotes, either single quotes or double quotes, depending on the context. Here, though, I'm going to change this to be student.name, and over here, I'm going to change it to be student.house. And that's just going to be my new syntax for getting the contents of what appears to be a class called student. Let me go ahead and rerun Python of student.py, enter. Let's type in Harry's name as before. Let's put him in Gryffindor, crossing our fingers as we often do. And Harry is indeed from Gryffindor. What, though, have I done? Let's introduce one other bit of terminology here. It turns out that I can create a class using that class keyword, but anytime you use a class, you're creating what are called objects. And here is the word objects as in object-oriented programming, or OOP. Let me go back to my code here, and even though I haven't really implemented much of it at all, I literally just left it with a ... That's enough code, lines 1 and 2, to just invent a new data type called student, capital S, that may or may not have some future functionality as well. That's enough to create a class. What, though, am I doing on line 11? On line 11, what I'm technically doing is creating an object of that class. So this, too, is another term of art. You create objects from classes. So if we go back to that metaphor that a class is like a blueprint for a house, or a class is like a mold, an object is when you use that blueprint to build a specific house, or something that comes out of in plaster, the mold, when you actually use that mold to create such an object. So a class is, again, the definition of a new data type. The object is the incarnation of, or technically instantiation of. And another term for objects would actually be an instance. You have instances of classes as well. So that's a lot of vocabulary, but at the end of the day, it just boils down to this. You can define your own class, which is really your own data type. You can then store attributes inside of it using this dot notation here, and then you can access those same attributes using code like this here. And now I have a proper student data type, and I don't have to kind of hack something together using a tuple or a list or even a dictionary. I now have a proper data type called student that the authors of Python didn't give me, I gave myself. Any questions now on classes, this new keyword class, or this idea of these objects or instances thereof?
Is the class object mutable or immutable?
A good question, and we've clearly laid the stage for having that conversation about every data type now. We will see that they are mutable, but you can make them immutable. So you can get the best of both worlds now by writing some actual code. And we'll write more code than the ... in just a bit. Other questions on classes or these objects thereof?
Then what would be the properties of those classes?
So at the moment, the properties of, or the attributes of, as I've been calling them thus far, would just be name and house. It turns out that there may very well be other attributes built into classes that we may see before long, but for now, the only two attributes that I care about are the ones that I myself created, namely name and house, are again what I would call attributes, and in a little bit, we're going to start calling those same attributes more technically instance variables. Name and house, as I presented them here in VS Code, are really just variables called name and called house inside of an object whose type is student. All right, so what more can we do with these classes? Well, again, on line 11 is where we're instantiating an object of the student class and assigning it to a student variable. We're then adding attributes name and house respectively on lines 12 and 13 currently. Both of those have values that are technically strings or strs, because that's what the return value of input is, but those attributes values could actually be any data type. We're just keeping things simple and focusing on defining students in terms of two strings, name and house. And then on line 14, we're returning that variable, we're returning that object to main so that we can actually print out who is from what house. Well, let's go ahead and add a bit more functionality here, because right now on lines 12 and 13, this is a little manual, and it's a little reckless of me to just be putting anything I want inside of this student object. It turns out with classes, unlike with dictionaries, we can actually standardize all the more what those attributes can be and what kinds of values you can set them to. So let me go ahead and do this. Let me propose that it would actually be really nice if instead of doing this here, let me go ahead and simplify my code as follows. Let me go ahead and give myself a local variable called name and set it equal to the return value of input, like we've done many times now already. Let me give myself one other variable for now called house and set it equal to the return value of input as well, prompting the user for their house. And now, instead of creating a student object from my student class and then manually putting the name attribute inside of it and the house attribute inside of it, let me actually do something more powerful. Let me do this. Let me call that student function, which is identical to the class name. Just by defining a class, you get a function whose name is identical to the class name with the capital letter included. But instead of just doing open parenthesis, close parenthesis, let me pass in the name that I want to fill this object with and the house that I want to put in that object as well. And now let me set the return value as before to be student equals like this. So what have I done that's different? Fundamentally, I'm still getting user input in the same way. I'm using input on line 11 and input on line 12, and I just so happen to be storing those return values in local variables. But now we're setting the stage for the more powerful features of classes and object-oriented programming more generally. Notice that I'm deliberately passing to this capital S student function name, comma, house. I'm passing in arguments to the function. Now, the student class is not going to know what to do with those yet, but now I'm sort of standardizing how I'm passing data into this student class, and ultimately it's going to give me an opportunity to error check those inputs to make sure that the name is valid, that it has a value, and it's not just the user hitting enter. It's going to allow me to ensure that it's a valid house, that it's Gryffindor or Hufflepuff or Ravenclaw or Slytherin, or not just hitting enter or some random value that the user types in. Because I'm passing name and house to the student class, this particular function, I'm going to have more control over the correctness of my data. So let's now go up to the student class, which up until now I left as just ... It turns out that in the context of classes, there are a number of not just attributes or instance variables that you can put inside, but also methods. Classes come with certain methods or functions inside of them that you can define, and they just behave in a special way by nature of how Python works. These functions allow you to determine behavior in a standard way. They are indeed special methods in that sense. Now, what do I mean by this? Well, let me go back to VS Code here, and let me propose that I start to define a standard function called underscore underscore, or dunder as it's abbreviated, init underscore underscore. And then I'm going to go ahead and do open parenthesis, and then I'm going to put in here literally the word self. More on that in just a moment. But now inside of this function, I'm going to have an opportunity to customize this class's objects. That is to say, this underscore underscore init method, or dunder init method, is specifically known as an instance method, and it's called exactly this. This is designed by the authors of Python, and if you want to initialize the contents of an object from a class, you define this method, and we'll see what it's about to do here. Let me go back to VS Code, and let me do something like this. Self.name equals name, and self.house equals house, but I don't want to just init this object very generically. I want this method called init to take in not just self, but name, comma, house as well. Now, what in the world is going on? Because there's a lot of weird syntax here. There's this dunder init method, double underscore, init, double underscore. There's all of a sudden this parameter called self, And then there's this new syntax, self.name and self.house. Now you're seeing really a manifestation of object-oriented programming. It's not all that different fundamentally from what we've been doing for weeks with dictionaries by adding keys to dictionaries. But in this case, we're adding variables to objects, aka instance variables to objects. Now what's going on? Let's do this in reverse. Let's go back to the line of code we wrote earlier. On line 15, I am treating the name of this class, student with a capital S, as a function. And I am passing in two values, name and house. What I've highlighted here on the screen on line 15 is generally known as a constructor call. This is a line of code that is going to construct a student object for me. Using synonyms, it is going to instantiate a student object for me. And again, how is it going to create that object? It's going to use the student class as a template, as a mold of sorts, so that every student is structured the same. Every student is going to have a name, every student's going to have a house, but because I can pass in arguments to this student function, capital S, I'm going to be able to customize the contents of that object. So if you think about the real world, if you've ever been on a street or a neighborhood where all of the houses kind of look the same, but they might be painted differently, they might be decorated a little bit differently on the outside, all of those houses might have been built using the exact same blueprint, sort of a mold, if you will, but then you can specialize exactly the finer points of those houses by painting the outside a different color or planting different trees. You can style them differently. Similar in spirit here. We have a student blueprint that's always going to have now a name and a house, but it's up to you and me to pass in any name and any house that we want. Now, where is this function? The fact that I'm calling student, capital S, and then a parenthesis and a close parenthesis with arguments inside suggests that there's a function somewhere in the world that has been defined with def that's going to be called. Well, as you might have guessed by now, the function that will always be called by definition of how Python classes work is a function called _init $_. Why? It's a crazy name, but it's what the authors of Python chose to just implement the initialization of an object in Python. Now, the only weird thing, especially weird thing I will admit, is this. It would be way clearer to me too if the only two parameters for init were just name, comma, house, right? That's how we've defined every function thus far in the class. You just specify the parameters that you want the function to accept. And indeed, that lines up with what I'm doing on line 15. I am only passing in two things to the student function. But it turns out that the authors of Python need to give us a little bit of help here, because suppose that you pass in name and house to this init method, and a method is just a function inside of a class. What are you going to do with the name and the house? Like literally, where are you going to put them? If you want to remember the name and the house for this student, you've got to be able to store those values somewhere. And how do you store them in the current object that has just been instantiated? Well, the authors of Python decided that the convention is going to be that this init method also semi-secretly takes a third argument that has to come first. By convention, it's called self, but you could call it technically anything you want, but the convention is to always call it self. And self, as its name implies, gives you access to the current object that was just created. What does that mean? Again, now on line 14, now that it's moved down a little bit, this line here is a constructor. It constructs a student object, but there's nothing in that object initially. There's no name, there's no house, but the object exists in the computer's memory. It's up to now you to store the name and the house inside of that object. How do you do that? Well, Python will just automatically call this init method for you, and it's going to automatically pass in a reference to an argument that represents the current object that it just constructed in memory for you, and it's up to you to populate it with values. And what this means is that inside of your init method, you can literally do self.name to create a new attribute, aka an instance variable, inside of that otherwise empty object and put this name inside of it. It allows you to do self.house and store that value of house. Now you could call these things anything you want. They could be n, they could be h as before, but that's really not very self-explanatory. Much better to do this kind of convention, self.name equals name, self.house equals house. And this is like installing into the otherwise empty object the value name and house and storing them in really identically named instance variables in the object. And again, an object is just an instance of a class. Now, I know that was a lot of vocabulary. That's a lot of weird syntax. So any questions on this init method, whose purpose in life, again, is to initialize an otherwise empty object when you first create it?
So what is the difference between the init method and default constructor?
A good question. So in other languages, if you program before, for instance, Java, there are functions that are explicitly called constructors that indeed construct an object, they initialize it with values. Python technically calls this init method the initialization method. It initializes the value. It's on line 15 now of my code. If I scroll back down, that I'm technically constructing the object. It turns out there's another special method in Python that we won't talk about in detail today called underscore underscore new underscore underscore that actually handles the process of creating an empty object in memory for us. But generally speaking, you, the programmer, don't need to manipulate the new function. It just works for you. Instead, you define your own init method here, an init function inside of your class.
Bueno, ya pasó una hora. Muchas gracias por acompañarme el día de hoy. Seguiremos estudiando la próxima clase. Y nada, eso es todo. Pasen bien. Nos vemos. Chao.